Okay, in chapter 3, we are talking about product design. And I want to remind everybody that when we talk about product design, we're looking at it in two dimensions. One is if you're a manufacturing operation that develops hard products and tangible products, or you could be in the service industry. And again, you have a different type of product design. It's more of what we call a soft product. But some of the characteristics that we talk about are the same and are there regardless of which type of industry or business you're dealing with. As we talk about that, we will be talking about the design process, which is very important. And as we talk about design, we're also carrying that into the subsequent steps of how you implement it too. So we're not stopping at the concept of a design itself. The design process is what we call a concurrent process, which means you just don't do it one module at a time, but as you're going through each step, you're anticipating what the whole picture or the whole result will look like. You have to consider the strategies for the new product or service that you're introducing. You have to keep thinking about the process you're going to go through and all of the related factors such as your supply chain. That becomes a factor in it too. And the other thing you have to always remember are the tools that you're going to use throughout the process, especially if you have a business where you have to not only design and engineer your product, but implement it and make it. And we have a lot of tools such as value analysis and modularity that we'll be talking about in that process. The over-the-wall concept means when somebody designs something without participating in any other input, they complete their part, throw it over the wall to the next guy, and each person works independently. Well, you never know whether it's going to come together until the end of the process. And if it doesn't, you have to send it back and redo it, which is a very expensive way of accomplishing that. On the other hand, by working concurrently, you're bringing in inputs in every step along the way and avoiding some of the redo and quality problems that you might have. You bring in technological factors, you consider capacity issues, you consider even some more logistical issues such as delivery, and especially what you consider is the impact on inventory, which we'll emphasize and talk about in later chapters. The type of strategies that get involved with new product introduction usually focus on several dimensions and forces. One is the market pull, which is a market-driven strategy that says we will make or create whatever the market will buy and what we can sell. Another aspect is the technology aspect, which is more into the process of inventing things and then telling the world that this is a better product. A lot of the electronics and internet stuff that we deal with today are examples of that. You actually create value that once you develop it and make it, you convince the market and the people in it that they can use it. And then there's the interfunctional way, and a good example of that is computers, which uses many dimensions that we're talking about and brings them all together. But whatever way you choose, you have to identify the strategies and develop them and take them to the next step of implementation. The development process is unique in its own because there are several steps in it. Usually a development process, whether it's a product or even a system, start with a concept. You try to identify a need, You try to create the idea and determine why you're doing it. Then you go into what we call the design stage, and that's where you're actually laying out, usually on paper, the concept in a more specific design, and whether it's a product or, again, a service or a process, you still go through the same thought process. You reach a point then after you have enough detail in the design where you need to test at least on a pilot basis. That is, and the reason for that is before you go into a full-scale production of multiple units, you want to see if the idea works, or do you have to go back to the drawing board and redesign it. That's what a pilot production is. It's an initial test of a model before you spend the money to go into multiple sets of productions. There are figures. Figure 3.2 in your textbook is a good example of what we're talking about, and of course there's a lot of material that you should read carefully to go with it. Look at each step, each element of the process. Try to understand first what each of those elements really represent and refer to, and then look at the whole concept as it fits together and make sure you understand how these elements relate to each other. We mentioned in earlier chapters the cross-functionality concept, and we need to remind ourselves of that. As you design products or systems, you have to look at how the individual parts are cross-functionally related. That is, in engineering, operations, marketing, even finance, have to be integrated into each other. And what's most important is, what is the end product and a total result going to look like? If you don't do that, you have what we call the alignment issue, which says, well, you're not really organized well, and you may have a good engineering or a good sales function, but your manufacturing or another part of the organization isn't marching to the same tune and fitting. Again, it's the issue of concurrency that's important. You're going to get a lot of illustrations in your textbook on this subject, and we're going to deal about it extensively throughout the course. The interesting thing is, if cross-functionality is so important, why don't each part of an organization see that and emphasize it? Well, there are a lot of reasons. It could be a communication issue. It could be individual agendas, people who worry more about their own role and don't care about, they're not necessarily team players. They become defensive about, they want to protect the things that they do and expect other parts of the organization to change to fit their needs. And sometimes there's logistical issues or priority issues. We will deal with each of those things. The important thing in cross-functionality is that it really is a very important factor in the supply chain concept. Without cross-functionality, without integration, your supply chain network, which on a global basis becomes even more complex and is more likely not to be effective if some of the parts don't work correctly. Likewise, what you do is going to impact your suppliers, which will come back and have a big impact on your operations. And in the same breath, customers become important in that supply chain. Your supplier is on the one end of the spectrum. The other end of the spectrum is the customer. So it makes sense, not just in a global basis, but on an integrated basis, that whole process is integrated together in a concurrent sense from supplier to customer. With respect to suppliers, you want to make sure that they're on board with the right technology, the right capability, capacity, and even their flexibility to be part of the team that you want to have working together. And at the other end of the spectrum, you want to make sure that you're part of the same team that your customer wants to have too. So there's several dimensions to that consideration. The other thing we're going to talk about in this chapter is the concept of quality function deployment, or QFD as we call it. It's really a quality dimension. It was developed in Japan and by Deming, who came from the United States and went to Japan, especially with Toyota, but with other companies as well, and showed them how to design more effectively, how to make products more effectively. Deming actually promoted the value-added concept as his key tool, and once people understood that, they understood some of the other quality aspects too. And in your textbook, you'll have illustrations of the QFD concept, so take a good look at each of those charts and make sure that you can understand them and relate them to the concepts that we are talking about. Now, another acronym and concept we want to emphasize in this chapter is Design for Manufacturing, or DFM. And that relates very importantly to the concurrency issue, because as you're designing something, just as we said earlier, you have to make sure that you can make it, or else you're wasting your time trying to design something that can't be made. And in doing so, we're going to use other tools such as value analysis and modular designs as part of our process. Value analysis, its primary purpose is to develop a product that it makes functionally better product or system and at the best cost or price. There's a lot of dimensions to it which we'll talk about, but you want to just always keep the purpose in mind. You want to enhance the design of a product or service. You want to make sure that you protect the quality of it and try to optimize the best price that it's going to take to produce it and sell it. We'll be talking about different examples of DFM throughout the course, and especially in this chapter. One thing to remember, probably Toyota is the best example of value analysis, not only in our textbooks, but throughout the world. That's probably the launching pad that Deming used, and it's been very successful. And we'll be looking at both examples and cases out of the Toyota case to illustrate some of the things we're talking about. Now, modular design, which is the other element or tool that we talked about along with value analysis, allows variety by mixing and matching different modules. You can create a inventory of module A, B, C, and D, and then you can combine them using different combinations to come up with product number 1, product number 2. So you don't have to reinvent the wheel and redesign each part of it. And this has some great cost benefits and efficiency benefits in the long run. We will talk about that and see some examples in this chapter. There are some, especially the automobile industry has some very good examples, not just in Toyota, but Volvo and Chrysler and other places as well. Okay, in summary, the design process here will focus on some of the strategies for a new product introduction. It'll focus on the development process, which we briefly touched about, cross-functionality, and the supply chain impact of it. We will always also talk about design tools such as QFD and design for manufacturing as important elements in that process.